In this chapter, we will cover audit sampling for the test of details of balances, including selecting sample size and samples from the population, as well as evaluating the sampling results. At the end of this chapter, you should be able to do the following. You should be able to differentiate audit sampling for the test of details of balances and for the test of controls and substantive tests of transactions. Be able to apply non-statistical sampling to the test of details of balances, apply monetary unit sampling, and be able to describe variable sampling. We will begin the discussion by differentiating audit sampling for the test of details of balances and for the test of controls and substantive tests of transactions. The main differences among tests of controls, substantive tests of transactions, and the test of details of balances are in what the auditor wants to measure. If the auditor's objective is to measure the operating effectiveness of internal controls, then the auditor would perform the test of controls. The auditor measures both operating effectiveness of internal controls and transaction accuracy in the accounting system by performing substantive tests of transactions. The test of details of balances is used to determine if account balances are materially misstated in the financial statements. On the next slide, we will discuss the application of non-statistical sampling to the test of details of balances. The application of non-statistical sampling to the test of details of balances is similar to the sampling used for the test of controls and substantive tests of transactions. The primary difference for the test of details of balances are when the auditor is planning the sample, when the auditor defines a misstatement, when the auditor specifies the tolerable misstatement and specifies acceptable risk of incorrect acceptance. In addition, in evaluating the results of the audit sampling for the test of details of balances, the auditor analyzes the misstatements. The first step in the audit sampling for the test of details of balances is for the auditor to state the objectives of the audit test. Auditors sample for tests of details of balances to determine whether the account balance is fairly stated. The next step is for the auditor to decide whether audit sampling applies for the audit. The audit sampling applies whenever the auditor plans to reach conclusions about a population based on a sample. The third step in the audit sampling is for the auditor to define a misstatement. Because audit sampling for tests of details of balances measures monetary misstatements, a misstatement exists whenever a sample item is misstated. The fourth step to the audit sampling is for the auditor to define the population to be used for the sampling. These are items making up the recorded dollar population. The auditor may separate the population into subpopulations before applying audit sampling. The fifth step in audit sampling for the test of details of balances is for the auditor to define the sampling unit. For non-statistical audit sampling in the test of details of balances, the sampling unit is almost always the items making up the account balance. The sixth step in the audit sampling is for the auditor to specify the tolerable misstatement. In here, the application of performance materiality to a particular sampling procedure is established. The seventh step is for the auditor to specify the acceptable risk of incorrect acceptance. The acceptable risk of incorrect acceptance is the risk that the sample supports the conclusion that the recorded account balance is not materially misstated when indeed it is materially misstated in the financial statements. And here, figure 17-1 shows the effect of acceptable risk of over-reliance and the acceptable risk of incorrect acceptance on substantive testing. When internal controls are considered or assessed by the auditor to be effective, the acceptable risk of over-reliance in this case is reduced, and a higher acceptable risk of incorrect acceptance is established by the auditor. The auditor then performs less substantive testing and increases the testing of internal controls. In contrast, when internal controls are assessed by the auditor to be ineffective, an acceptable risk of over-reliance is established at 100%, and the acceptable risk of incorrect acceptance is then lowered by the auditor. The auditor also will perform extensive substantive testing and no test of controls. You can find figure 17-1 on page 569 of your textbook. The 8th step in audit sampling for the test of details of balance is to estimate misstatements in the population. An auditor typically makes this estimate based on prior experience with a client and by assessing inherent risks, considering the results of the test of controls, substantive tests of transactions, and the analytical procedures already performed during the audit. The 9th step in audit sampling is to determine the initial sample size. When using non-statistical sampling, the auditors determine the initial sample size by considering the factors such as inherent risk, control risk, results of other substantive procedures, tolerable misstatement, expected size and frequency of misstatement, the dollar amount of population, and the number of items in the population. These factors are summarized in Table 17-3 on page 570 of your textbook. The 10th step in the audit sampling is for the auditor to select the sample. The auditing standards permit the auditor to use any of the selection methods that we discussed previously in Chapter 15. In here, we have Table 17-3 as mentioned in the previous slide. It summarizes the factors influencing sample sizes for the test of details of balances, including conditions leading to smaller or larger sample size. For example, if inherent risk is assessed by the auditor as being low, then the auditor would consider a smaller sample size from the population of account balances being tested. If inherent risk is assessed as being high by the auditor, then a larger sample size will be used by the auditor for the audit. In contrast, if a larger tolerable misstatement is established, the auditor in this particular case would require a smaller sample size. A smaller tolerable misstatement would require a larger sample size for an audit. You can find Table 17-3 on page 570 of your textbook. The 11th step in audit sampling for the test of details of balances is for the auditor to perform the audit procedures as planned for the audit. The auditor applies the appropriate audit procedures to each item in the sample to determine whether it contains a misstatement. The 12th step is to generalize from the sample to the population and for the auditor to decide the acceptability of the population. The auditor should generalize the sample to the population by projecting misstatements from the sample to the population and considering sampling risk. This starts with calculating a point estimate, which is usually done by assuming that the misstatement in the population is proportional to the misstatement in the sample. The 13th step is for the auditor to analyze the misstatement. The auditor must evaluate the nature and cause of each misstatement found in the test of details of balances. And the last step in audit sampling for the test of details of balances is for the auditor to decide an action to be taken when a population is rejected. When the auditor concludes that the misstatement in a population may be larger than the tolerable misstatement, after considering sampling risk, the auditor has several courses of action to take. The auditor can take no action until the tests of other audit areas are completed, or the auditor may perform expanded audit tests in specific areas. The auditor may increase the sample size. The auditor may adjust the account balance. The auditor may request the client to correct the population, or the auditor may refuse to give an unmodified opinion. In the next slide, we will cover the application of monetary unit sampling. Monetary unit sampling is the most common statistical method of sampling for the test of details of balances because it has the statistical simplicity of attribute sampling, yet it provides a statistical result expressed in dollar amounts. The difference between monetary unit sampling and non-statistical sampling is that the definition of the sampling unit is an individual dollar. The population size is the recorded dollar population. Sample size is determined using a formula. Sample selection in monetary unit sampling is done using probability proportional to size sample selection. And lastly, the auditor generalizes from the sample to the population using monetary unit sampling. When using monetary unit sampling, the auditor decides the acceptability of the population. The auditor compares the calculated misstatement bound to the tolerable misstatement. If the misstatement bound exceeds the tolerable misstatement, the population is not considered acceptable by the auditor. The following factors are used in computing sample size in monetary unit sampling. These factors are the acceptable risk of incorrect acceptance. This factor is dependent on the audit risk factors. The recorded population value, which is the dollar value of the population taken from the client's records. And lastly, the tolerable misstatement, which is generally the same as performance materiality. The following factors are used in computing sample size when using monetary unit sampling. The tolerable misstatement as a percentage of the population value. The estimated population misstatement. This is usually based on the sample results for the prior year. The ratio of estimated population misstatement to the tolerable misstatement. The auditor uses data similar to what is shown on Table 17-5 on page 578 of your textbook to determine the appropriate confidence factor based on the auditor's judgment of acceptable risk of incorrect acceptance and the ratio of expected misstatement to the tolerable misstatement. In here, we have table 17-5 as mentioned in the previous slide. It illustrates the confidence factors for the sample size design using monetary unit sampling. You can find table 17-5 on page 578 of your textbook. The following factors are used in computing the sample size. Sample size is calculated by taking the confidence factor and dividing it by the tolerable misstatement. The sampling interval is calculated by taking the population recorded amount divided by the computed sample size. In here, we have table 17-6 that summarizes the steps to calculate the sample size in monetary unit sampling as discussed in the previous slide. You can find table 17-6 on page 579 of your textbook. If the entire sample is audited and no misstatements are found in the sample, the auditor may conclude that the recorded amount of the population is not overstated by more than the tolerable misstatement established at the specified risk of incorrect acceptance. The upper limit when no misstatements are found is the confidence factor for no misstatements multiplied by the length of the sampling interval. The upper limit is also referred to as the basic precision. In here, we have table 17-7 that shows the confidence factors for monetary unit sample size evaluation. You can find table 17-7 on page 580 of your textbook. When misstatements are found, the auditor calculates a projected misstatement and an allowance for sampling risk. The projected misstatement is the percentage misstatement times the sampling interval. The projected misstatement is increased by the allowance for sampling risk, which is calculated as the basic precision plus an incremental allowance for sampling risk for each misstatement found in sampling units that are smaller than the sampling interval. Now, auditors must understand the relationships of the three independent factors in the audit risk model. Table 17-10 provides an example of the incremental changes in the confidence factor for 5 misstatements and a 5% acceptable risk of incorrect acceptance. You can find table 17-10 on page 581 of your textbook. Monetary unit sampling appeals to most auditors for at least 4 reasons. First, monetary unit sampling automatically increases the likelihood of selecting high-dollar items from the population. It often reduces the cost of doing the audit testing because several sample items are tested at once. It is easy to apply. Samples can be evaluated by the application of simple tables. And lastly, monetary sampling unit provides a statistical conclusion rather than a non-statistical one, providing a better and more defensible decisions for an auditor. There are 2 main disadvantages of monetary unit sampling. The first disadvantage is the total misstatement bounds resulting when misstatements are found may be too high to be useful to the auditor. To overcome this problem, larger samples may be required for the audit. And the second disadvantage is that it may be cumbersome to select proportional to size samples from large populations without computer assistance. For all of these reasons, auditors commonly use monetary unit sampling when zero or few misstatements are expected from the audit, a dollar result is desired, and the population data are accessible in electronic format. Moving on, we will now cover variable sampling. Like monetary unit sampling, variable sampling is a statistical sampling method. These two methods share many similarities. It is useful to understand sampling distribution and how they affect the auditor's statistical conclusions. The auditor does not know the mean value of misstatements in the population, the distribution of the misstatement amounts, or the audited values. These population characteristics must be estimated from the samples. The auditor calculates the mean value of items in the sample by dividing the sum of the value of each individual sample item by the sample size. After this calculation of each sample, the auditor plots them into a frequency distribution. As long as the sample size is sufficient, the frequency distribution will appear much like that as shown in Figure 17-3 on page 584 of your textbook. The distribution of the sample means such as this is normal and has all the characteristics of the normal curve, where the curve is symmetrical and the sample means fall within known portions of the sampling distribution around the average or mean of those means. Furthermore, the mean of the sample means is equal to the population mean. Figure 17-3 is an illustration of the frequency distribution of sample means as mentioned in the previous slide. You can find Figure 17-3 on page 584 of your textbook. With this information, the auditors can make the tabulation of the sampling distribution. To summarize, three things shape the results of the experiment of taking a large number of samples from a known population. The mean value of all the samples is equal to the population mean. The shape of the frequency distribution of the sample means is that of a normal distribution as long as the sample size is sufficiently large, regardless of the distribution of the population. And lastly, the percentage of sample means between any two values of the sampling distribution is measurable. When samples are taken from a population in an actual audit, the auditor does not know the population's characteristics, and ordinarily only one sample is taken from the population. But the knowledge of sampling distribution enables auditors to draw statistical conclusions or statistical inferences about the population. An example of this process is shown on page 585 and 586 of your textbook. Auditors can state the conclusions drawn from a confidence interval using statistical inferences in different ways, taking care to avoid incorrect conclusions because the true population value is always unknown. Auditors use the preceding statistical inference process for all of the variable sampling methods. The three variable methods include the difference estimation. The auditors use difference estimation to measure the estimated total misstatement amount in a population when both the recorded value and an audited value exists for each item in the sample. The second variable is ratio estimation. Ratio estimation is similar to difference estimation, except the auditor calculates the ratio between the misstatements and their recorded value and projects this to the population to estimate the total population misstatement. And the third variable is the mean per unit estimation. In mean per unit estimation, the auditor focuses on the audited value rather than the misstatement amount of each item in the sample. As with other stratified methods, the population is divided into two or more subpopulations. Each is independently tested and evaluated, and the results of the sampling is combined. This can be used with any of the variable methods, but is most commonly used with the mean per unit estimation. In addition to the acceptable risk of incorrect acceptance, auditors also use acceptable risk of incorrect rejection for variable sampling. The acceptable risk of incorrect acceptance is the risk that the auditor accepts a population that is materially misstated. In contrast, the acceptable risk of incorrect rejection is the risk that the auditor has concluded that a population is materially misstated when in fact it is not. These are illustrated in tables 17-12 and 17-13 of your textbook. Please complete the required evaluation method for Chapter 17 as it will be part of your final grade. Use Blackboard to complete the requirements. You have reached the end of the course presentation for Chapter 17.